So in today's video, I'm going to show you how to attain 80,000 IOPS in an Ec2 instance for Windows. As you know, if you check the Amazon Ebs volume, EBS is the block storage solution in Amazon Web Services. So if you check the documentation for Ebs volumes, you can see there are different types of Ebs volumes available. There are 4 different types of Ebs volumes, each one optimized for a different purpose. 2 of them are solid-state drives, and another 2 are hard disk drives. So when we want to achieve maximum IOPS, obviously we will be looking at solid-state drives. One of them is called General Purpose SSD, which gives you burst capacity. The other one is Provisioned IOPS, which gives you a deterministic and predictable performance, and IOPS throughout the lifetime of your workloads. Okay, if I scroll a bit down, you can see the max IOPS per volume for GP2 is 10,000. For IO1, which is the one I'm going to use today, it's 32,000. But a bit further down, it's showing max IOPS for instance. It's 80,000 for all these Ebs volume types. So if max for single volume is 32,000 or 10,000 or 500 or 250, how can you achieve 80,000 per instance? Obviously by combining more than one volume, and the aggregate IOPS can be up to 80,000. And I'll show you how to do that. So first thing to do is to choose the proper instance type. There are different Ec2 instance types in this AWS page. Amazon EBS optimized instances. You can see the maximum IOPS available on each instance type. Not all of them will give you 80,000, but some of them do. For example, C5 18X large gives you 80,000 IOPS. Also C5D 18X large, or for example G3 18X large, and so forth. So if you scroll down through this list, you can see many different instance types providing 80,000 IOPS. I'm going to use C5 18X large today. So I'll go to AWS console, EC2 console, launch an instance. I'll use Windows Server 2016, launch an instance, and I'll choose C5 18X large. Okay, I'll have to choose my VPC. I'll use my VPC A, which I had created before. I'll choose my private subnet, A2, and to make it easier for myself to log into my instance, I choose my managed directory, but this is not mandatory. You can also do this on standalone single instances. No need to join to Active Directory at all. Okay, and now I'll have to create and provision storage. So I want sum of all IOPS on my volumes to be 80,000. I'll use first volume with 500 gigabytes. Volume type is provisioned IOPS, and I'll provision 20,000. I can ensure it will delete on termination for cleanup. I can also add the encryption. And the last one, Okay, now I have to add a tag. I'll give it the name Max IOPS. For security group, I'll use an existing one. Bastion RDP, because I want to RDP into it. Now my Ec2 instance is being provisioned. Once it's up on available, I can log into my instance and stripe those volumes together to achieve 80,000 IOPS. While we're waiting for the instance to be provisioned, the technology that I'm going to use to stripe these volumes is storage spaces in Windows Server. There are also other alternatives. You could use older technologies, but I would recommend using storage spaces. Storage spaces has been available since Windows Server 2012, and it's available also in newer versions of Windows. Storage spaces can be used in single instances. There's another alternative called Storage Spaces Direct, which can be used in Windows clusters. Windows Storage Spaces Direct is also based on the storage spaces. Under the hood, Storage Spaces Direct is also leveraging the capabilities of the Windows Server storage spaces. To provide the same soft NAS features across a Windows Server failover cluster. To make it simple, I'm not going through a Windows Server failover cluster. I'll just show you how to do it in a single instance, but the same thing also applies in a failover cluster. You can do the same thing in a failover cluster. The only difference is that instead of directly using storage spaces, you have to use Storage Spaces Direct. And we have a documentation page detailing how to do that in a Windows Server failover cluster. Okay, let's have a look. This is the IP of my instance. I'm going to use it through my Bastion host. Let's see what we have here. I have only the C drive, which is 30 gigabytes. No other drives are attached. If I go to disk management, I should be able to see all of the additional ones. 1, 2, 3, 4. I'm not going to initialize it here, but you can see the disks are available. Disk 1, 2, 3, and 4. There's 4 of them. All right, I'm going to use PowerShell. I've got a number of commandlets. Let's paste them here in PowerShell ISE so we can see them better. Okay. So first defining drive as E. That's good. There are 2 commandlets here. If you've already configured storage spaces and you want to clear it and do it again, you can run these 2 commandlets. Since I haven't done it yet, I'm just skipping them. And I'm going to run this commandlet, new storage pool. This will create the storage pool out of all the EBS volumes that I have. Here I have 4 EBS volumes, so this commandlet would create a common storage pool out of those 4. So it's an abstraction on top of those 4, which gives a unified storage pool. New storage pool, friendly name concrete pool, storage subsystem friendly name, Windows storage, physical disks, get physical disks, whatever is there. Let it run. Okay, there it is. I have my storage pool created. So now I can label my disks in the storage pool as SSD or HDD. So if you have different disk types, some of them fast and some slow. Storage spaces enables you to create a storage hierarchy, putting the SSD types, the faster volumes, as cache tier, and the cheaper and slower volumes for more capacity, therefore creating a trade-off between your storage solutions. But since here I've created only 4 EBS volumes, all of them of the same type, there's no need to do that. So I'll skip that commandlet and just move to creating a new virtual volume. I'll create one virtual volume. For example, size here is 87 gigabytes. Resiliency setting name is simple and provisioning type is fixed. There are 4 ways you can do this. It's very flexible. But I'm just doing a simple version. Okay, the virtual disk is created now. Next thing I have to do is create a partition on top of this virtual disk. Friendly name vdisk1. Here it is. My partition is created. Next, I have to format my partition, which I can do with this commandlet. Format, volume, drive letter. And before that, let's go have a look what happened here. As you can see, Windows has detected the new volume. New disk has become available and it's offering to format it. I can also do it from here. Selecting capacity and file system. You can either do NTFS or REFS. I'm going to choose Resilient File System because that's the recommended file system for many use cases. And it gives you better performance. And it has lots of improvements over NTFS. You get different allocation sizes. In Windows 2019, you get even more choices here. Let's just stick with 4096. Volume label, let's call it Vol1. Okay, format complete. And now I have this Vol1 of size 86 gigabytes available here. Now I'm going to test the IOPS on this newly created volume. For that, I need a test tool, and I'm going to use Disk SPD, which is a tool published by Microsoft for this purpose. You can test the speed of a disk inside Windows with this tool. I'll copy them. The same drive, or it can be anywhere else as well. It doesn't have to be on the same drive. I'm opening the command line window. Let's maximize it. All right, Disk SPD is an exe file, and it has a number of parameters. Now, you can refer to the documentation of Disk SPD to see what parameters would work better with your cases. One of the good things about Disk SPD is that it can also simulate SQL Server I/O behavior. So here, for instance, we're doing something similar to that. This parameter, -C60G, is showing 60 gigabytes for the target test file. -D60 is the duration of the test. 60 means 60 seconds, so I'm doing it for 1 minute here, but you can extend it or reduce it to any number that suits better to your purpose. -R shows that there will be read operations. -W0 shows 0% of operations is write. Therefore, in this case, I'm doing read-only IOs. -T8 shows the number of threads. I'm using 8 threads. And -O32 and -B8K, which is the block size, and -H and -L, and test file name. Let's see what the result is going to be. One of the things you notice is the block size, which is a very important parameter. When you're thinking about the IOPS, number of IOs per second depends on your block size. So if you expand the block size to a much bigger number, such as 256, what will happen is that you will increase your throughput, but your IOPS will drop. You can have less number of I/O operations during the same time. But with that less number of I/O operations, you're reading and writing a larger amount of data. So your throughput will increase. But your IOPS will diminish. This is very important. You have to tune your operations based on this. If you want more throughput, you have to increase block size. If you want more IOPS, you have to decrease block size. So here are some results. Since this was just read transactions, I'll check the first table as you can see here. Number of IOs per second. The aggregate number throughout all of the threads that we're running is 79,970. If I run this test run for a longer time, this will hit exactly 80,000. Sometimes might even exceed 80,000 a little bit. And the average latency is 3 seconds. And the megabytes per second, which is the throughput, is 624. Okay, now let's have a look at what will happen if I increase 8K to 16K. I'm expecting to receive almost the same results, but in terms of IOPS, I would probably attain the same number of IOPS, but for throughput, it should probably increase. Let's see if that happens. And if I further increase, definitely my throughput will increase and my IOPS will decrease. Okay, I got good results. Now my IOPS is almost the same, 79,942.32. But my throughput doubled. It's now 1,249 instead of 500. So if I go back here, you can see the throughput was 624. From 600, we're hitting 1,200. It's almost doubled because I doubled the block size. Although my IOPS has remained the same, which is telling us the optimized block size is 16 kilobytes. You should keep that in mind. When you're writing your applications or optimizing your applications for Ec2 instances. The optimized number is 16 kilobytes. Now let's increase that to 32 kilobytes and we'll run the same test. Now I expect my IOPS to drop at this point, but my throughput to further increase. Here are the results. IOPS has decreased. It's no longer 80,000, it's 53,000. But my throughput has further increased from 1,200 to 1,600. And if I continue increasing my block size, again, my throughput will continue increasing. And my IOPS also will continue to decrease. That's it. We've seen how to attain the maximum IOPS on EC2 instances, and we've also seen how we can optimize our IOPS and throughput using the block size. Thanks for watching.